Hi, Ananda. Myself, Tanush R. I am pursuing engineering in the Oxford College of Engineering, and I thank emertxe to give me such an opportunity to study about embedded system as an internship. And our group is of three members, which will be an Shubham and myself, Tanush R. The main project overview is introduction to C, data types, operation variables, array and pointers, function strings, storage classes, conditional loops, introduction to embedded system and microcontroller, and we are going to learn about GPS and embedded system, the difference between them. Tools installation. M- MPLAB XIDE is used to write code. XC8 compiler, which is used to compile the code, and PiximLab is used to execute the code which is being given. Introduction to various peripherals of 16F877A microcontroller. Project requirement and designs are also explained here. Embedded C programming for interface matrix keypad 16 into 4 LCD is used, and LED buzzer, ISR and cooler are used in this microcontroller. And the embedded system is a specialized computer system designed to perform specific tasks within the large device or product, often in real time. Example are washing machine and ABS, where washing machine is used embedded system to wash clothes and give the output, whereas ABS is an anti-lock braking system which is used in vehicles for safety measurements. What is a microcontroller? A microcontroller is a computer on an IC. It consists mainly shown in diagram: CPU, RAM, input output, peripherals, ROM, timer, serial port, etc. And now here we are going to see the difference between GPS, which is general purpose computer system, and ES, embedded system. The general purpose system contains a system which is combination of generic hardware and general purpose operation system for executing various applications, whereas embedded system only executes specific set of applications, and it is specified purpose is in only hardware, where OS in GPS is consists general purpose operating system, GPOS, where embedded system doesn't contain any operating system for functioning, may or may not contain operating system for functioning. Alterations are applicable in GPS, where there are in embedded system pre-programmed, and it is non-alterable by end users. Key facts in GPS are: performance is a key deciding factor in selecting of system faster is better, whereas application specific requirement like performing power requirement, memory usage, and key different factors. The power consumption is more in GPS, whereas in embedded system it consumes less power. Response time is not critical, but in embedded system it is critical for some applications only. Execution need not to be deterministic, where embedded system is deterministic for certain types of, yes, like hardware, real-time systems, etc. Pixim Lab peripherals hardware. It made the Pixim Lab peripherals are compared the below shown hardware units, which are microcontroller, that is PIC16F877A, LCD display, keys, buzzers, fan, and timer, etc. And this is the architectural structure of PIC167A IC, where we can see all the components which are connected, which each and every pin has specific functions of their own. And this is the pin diagram of IP of the chip IC, where each and every chip now will be explained here. Where the pin 1 is a master clear input voltage programming pin used to reset microcontroller, where pin 2 is an analog input channel 0, and digital input pin can be used in digital output, analog to digital conversion. where pin 3 is analog input channel 1 and digital input similar to RAO. It can be used for both analog and digital purpose, where pin 4 it can be used for both analog and digital purpose, but it has analog input channel to digital input output system, where pin 5, which is ICPCLK, analog channel 3 reference voltage capacity. It has multiple functions including analog input output serials as other pins, where pin 6 is a time clock, zero input calculator, IPC data communicating, and pin 7 is analog input channel 4, slave select. It is SPI. Input and SPI communications are multiple functions including analog input, where pin 8 and pin 9 has port E0, but in pin 9 it has port B1, which is pin 8 is used to read control signals analog input, but here it used to read a control system analog input in channel 6. And pin 10, which has port E bit 2, chipset SPI, and VSS is a ground, which is pin 11. VDD is supply voltage. Pin 13 is an external or oscillating input or a clock, which is used for oscillating input. Pin 14 is external oscillating output. Pin 15 is a timer 1 oscillating, where all these pins has separate PC to everything, which is SPI and USART for transmitting data, etc. And now we can see the pins like VDD and VSS, where VDD is specified as supply voltage, as in pin 33 and pin 35, where VSS is ground and pin 34 and 36. Zero voltage is a ground reference, where supply voltage is specified voltage. Pin 37 is input, is an in-circuit signal programming data, whereas in pin 38 is in-circuit signal programming clock. Pin 19 is a keyboard interrupt, and finally the pin 40 is a capture, compare, PWM3, CCP3 function, programming or data memory select. These are the pins provided for function range. Now coming to the project, we have worked on the micro oven, and micro oven is a oven which cooks food very quickly by electromagnetic radiation rather than by heat, which uses electric magnetic radiation. Futures. There are four futures. There are four modes in the microcontroller, which is micro mode, grill mode, convention mode, start mode. Where micro mode is a default mode. It is a microwave cooking mode, which is used to microwave radiation of heat food. You can adjust the cooking time and level as needed. The maximum power is given. We have given is 900 volts, 900 watt. Grill mode. Micro one has grill mode for boiler function, which in this grill mode it only heats the top elements of top and bottom surface. Bottom it helps in browning and crisping the food. Example like grilled cheese sandwich for heating frozen items, and it can be used time accordingly. Convection mode. This is mode where we can preheat the oven, and we can give the supply whatever we need. We can cook whatever we need after preheating in the convection mode and start. It is the mode of microwave. Once starts, it operates with 30 seconds. This can be also incremented by 30 seconds. Requirements: basic embedded C, pin configuration, MPLAB X IDE, XC8 compiler, PiximLab. The main components in PiximLab we have used are a microcontroller, which is PIC16F877A, an LCD display 16 into 4, matrix keypad, cooler, and buzzer. Now going to the program. This is the main program where we have included header file, main h, and the header files we have included are these define screens, which are power on screen, menu display, and all these define screens where we have used pins for each and every pins, as like we can see fan, buzzer, every header file has its own pin. And coming to the main program, we have used our fan for offing and turning on the buzzer, everything, etc. Where it is set for 0, and we can start using the keys. Where else key one is microwave mode for resetting. The maximum power for supply for the micro oven is 900 volt, as I said below for bit pin. And key 2 it is used for grill mode. Key 3 is conventional mode. Key 4 is start mode, etc. And these are all the keys where all keys are explained and display where it has been shown off and on state and a break state, etc. Now we are going to see the fixing how does the micro oven works. Here we can see four modes: micro, grill, convention, and start mode. Now we are going to see the micro mode. It has 900 watt, and we can set a time for like that 10 seconds, and where this star is used to clear the input given, and again I had entered the input, and hash is used to enter the input. Now as I entered, the microphone starts running, where cooler works, heater passes heat, and finally buzzer buzzes. Now the micro mode is done, and next is the grill mode. In this grill mode also we can set certain time for minutes or seconds, whatever we need. Now I'm going to set for 30 seconds, and hash it helps for entering the given input. Yes, now it is running. And here we can see pin 5, which helps in pausing. If we want to pass the microwave, pin 5, which is used to pass the microwave, where 4 starts the microwave. And now pin 6 will stop completely the running of microwave. Now there it is 14 seconds. Now if I click 6, it completely stops. And now third mode is convection mode. This mode where we can preheat the oven. Preheat the oven. Now we can see we can uh, we can set time for 10 seconds. Example, 1 minute, 1 second. Sorry, this is not the. It is set time setter, and now I'll press the reset to start it again. I'm showing the convention mode. In convention mode, we have set minimum temperature to 180 degrees. Yes, here we can see. If we give the temperature above 180, like 185, it will show as less than 180 degrees. Now I'm going to set like 22 degrees Celsius and enter. Now we have set a default time for 18 seconds where it starts preheating the oven. After preheating, then it starts. Then after preheating, we can set a timer like whatever time we can. Now I'm going to set 10 seconds and start the process where it will start heating the food again.